Important topic, that is transpose of a matrix. Let's say we have a matrix A given by Aij. This is the usual notation that we use for a matrix. So A is Aij and it is M cross N. Then the matrix obtained by interchanging the rows and columns. Interchanging, that is, rows are now columns and columns are now rows. That matrix is called the transpose of the original matrix. So, and it is denoted like this: A dash or A to the power T. Both notations are in use, but generally you will find A dash. So this means rows and columns are interchanged. That is, Aij becomes Aji, and so this M cross N becomes N cross M. Okay. Let's understand this. Let our matrix be 1, 2, 3, A, B, C. I have used different notations so that it is easier to understand. If this is this, what I said, transpose is when this row will become column and column will become row. So what will be the transpose? This is 1, 2, 3, 1, 2, 3. So this now becomes 1, 2, 3, and this is A, B, C. So you can see this was 1A was column, now 1A is row, 2B was column, 2B is row, 3C was column, 3C is row. Similarly 1, 2, 3 now column, ABC column. You get it? Let me give you one more example. Let's say our matrix is X. It is X1, X2, X11, X12, X13, X21, X22, X23, then X31, X32, X33. This is our matrix. Now this row will become column. So X dash will be X11, see X11, X12, X13, X12, X13. This will now X21, X22, X23, then X31, X32, X33. Clear? The rows are now column and the columns are now rows. This is a square matrix. A very peculiar feature is that the diagonal matrix is same. You can see. We'll discuss about this later on, but just for the sake of knowledge, you can see this is X11, X22, X33. The matrix is, the diagonal is same for the two matrices. Okay. Now let's see the properties of transpose of a matrix. What are the properties? So let's see the properties of transpose of a matrix. First property is that the transpose of a matrix is the original matrix. Obviously, this will be this of this, because in the first case rows became column. The second one will make that column again as row. So this is the first property. Keep this in mind. Second, if a matrix is multiplied by Ka and we take transpose of it, it is equal to this. K can be taken out. Why? Because K is multiplied to each and every element. So whether it is in row or column, it doesn't matter. So it can be taken out. This is the second property. Clear? Let me explain this. Let's say this is our matrix. We multiplied it. Okay. So this became this. Now we take transpose of this. What will this be? Now it will be Ka1, Ka3, Ka2, Ka4. So transpose of this will be this. You can take K out. A1, A3, A2, A4. So K can be taken out. Clear? The third property is very important. A plus B bar. What will be if we have addition of two matrices, then what will be the transpose of sum of two matrices? It is simply A dash plus B dash. Learn it by heart. Fourth is, what will be the transpose of sum of two matrices? It's like this, but it will reverse. This will become B dash into A dash because of conformity, M cross N cross M. So this becomes B transpose A transpose. Clear? Now we'll see some questions, some examples to understand this. So we are given with two matrices A and B, and we have to verify these three properties that we just saw. So first is transpose of A, whether it is equal to A or not. Let's see what is A transpose. A transpose will be, this is row, this will become column. So this is root 3, 2. This is 4, 2, 0. This is A transpose. Now let's take transpose of this. This will become, the column will become row. You can see this is same, this is equal to A. Therefore, first is verified. Clear? Let's see the second one. KB dash equal to KB whole dash equal to KB dash. Let's first of all let's see what is KB. KB will be 2K minus K 2K. This is K 2K 4K. Okay. And what will be the transpose of this? Transpose of this will be row will become column. So this will be 2K minus K 2K, and this is K 2K 4K. So this is our left hand side. Now we'll take KB dash. So first of all, let's see what is B dash. B dash is equal to 2 minus 2 minus 1 2 1 2 4, and let's multiply it with K. What we'll get? This will become K into this will become 2K K minus K 2K 2K 4K. Now you can see this is equal to this. Therefore, KB whole dash is equal to KB dash. Clear? The fourth one, A plus B dash. First of all, let's see what is A plus B. A plus B will be this plus this. So this will become 3 plus 2 5 root 3 minus 1. Root 3 minus 1, 2 plus 2, 4. 4 plus 1, 5, 2 plus 2, 4, 0 plus 4, 4. Okay. Then take a dash of this, that is transpose of this. This will become 5 root 3 minus 1, 4. This is 5, 4, 4. So this is the left hand side. Let's see the right hand side. First of all, we'll take A dash, then add it to B dash. So what is A dash? A is this, so this becomes 3 root 3, 2. 4 2 0 4 2 0. And what is B dash? It is 2 minus 1 2 1 2 4. So this becomes 3 plus 2 5 4 plus 1 5 root 3 minus 1. See, root 3 minus 1, then 2 plus 2 4 2 plus 2 4 0 plus 4 4. So this is equal to this, you can see. So A plus B dash is A dash plus B dash. We have matrix A and matrix B, and we have to verify that AB dash is equal to B dash A dash. So first of all, let's take AB dash. Let's say AB first. What will be AB? This is 3 cross 1 and this is 1 cross 3. So the product will be 3 cross 3. So minus 2 into this, into this, into this. So this is minus 2, minus 6 and plus 12. Then 4, 12, minus 24, 5, 15, minus 30. So this is AB. What will be AB dash? This will be transpose of this. That is minus 2, minus 6, 12, 4, 12, minus 24 and 5, 15, minus 30. 5, 15, minus 30. So this is AB whole dash. Now we have to see B dash into A dash. B dash, A dash. What is B dash? B is there. So we have 1, 3, minus 6. This is B dash into A dash. Okay, this is this. So this will be one matrix. This will become minus 2, 4, 5. Okay. So this into this will become minus 2, 4, 5. Minus 2, 4, 5. Then multiplied by 3. So this is minus 6, 12, 15. This is minus 6 into this. So this is 12, this is minus 24, this is minus 6 into 5, minus 30. These two are equal, you can see minus 2, 4, 5, minus 6, 12, 15, 12 minus 24, minus 30. Therefore, AB whole dash is equal to B dash A dash, verified. Okay. Two very important concepts. Symmetric matrix. Let's say we have a matrix A given as Aij. Let this matrix be M cross N. If Aij is equal to Aji, all the elements, Aij equal to Aji, that is if A12, then this is equal to A21. A13 means equal to A31. If we have such a matrix, we say that the matrix is symmetric. For example, let's see a 2 cross 2 matrix. We have A and we have B at diagonal. What we are saying? We are saying Aij, that is this matrix. Let's say this is C, then this has to be C. The diagonal is clear. All the elements below the diagonal and above the diagonal, they are same. Not all the elements, corresponding elements are same. So it is a symmetric matrix. Let's see for a 3 cross 3 matrix. This is A11, this is A21, this is A31, this is A22, this is A32, and this is A33. I told you this matrix is equal to this. 21 is equal to 1, 2. Below the diagonal, the corresponding elements are same, below and above the diagonal. So this becomes A21, this is A31, this is A32. See? So that if we interchange the row and columns, it remains same. See for yourself. If this column becomes row, there is no difference. And it is possible only for square matrix. That is, the definition of this will be that if for a square matrix Aij is equal to Aji, that matrix is called a symmetric matrix. And from here we have a theorem. See, this is possible that the column becomes row or the column is equal to the row. This is possible only when A is equal to its transpose. So the theorem is that if a matrix is equal to its transpose, then it is a symmetric matrix. Clear? Now here, very simple, if Aij is equal to minus Aji, if in a square matrix Aij is minus Aji, we call it a skew matrix. See, skew matrix. Aij is minus Aji. That is, if this is this, that is, this is minus of this, this is minus of this, this is minus of this, then that matrix is called that matrix is called skew matrix. Clear? So if we think this is a mirror, in case of symmetric matrix, this was mirror image, and in case of skew symmetric matrix, this is negative of the original image. Clear? One more thing we have to see for skew matrix, skew symmetric matrix. I told you Aij is equal to Aji. Clear? What when I is equal to j? In case of I equal to j, this, let's say Aii equal to minus Aii, is skew symmetric. Aij is minus Aji. So this is this. How is this possible? Aii can be equal to minus Ai means 2Aii is equal to 0, that is Aii is 0. This is a very important characteristics of skew symmetric matrix, that all the diagonal elements are 0. Clear? Now let's say a theorem. It says that A plus A dash, that is transpose of that matrix, it is a symmetric matrix, and A minus A dash is skew symmetric. How? Let's say B is a matrix A plus A dash. Okay. Then this implies B dash will be A plus A dash dash, but we know that A plus B dash is A dash plus B dash, that is A dash plus transpose of transpose, and we have theorem that transpose of a matrix is the original matrix, so this becomes A dash plus A, but we know that A plus B is B plus A in matrix, so this is now A plus A dash, but what is this? A plus A dash is B, so this is B. Now B dash is B, this we know, this is true only for symmetric matrix, so A plus A dash is a symmetric matrix. Similarly, let's say this is this, then B dash is A minus A dash. Okay, so this becomes A dash minus A, so this is A dash minus A. Clear? But what is this? This is minus of this, so this is now minus B, and we have seen that if the transpose is minus of that matrix, what is the meaning? It is a skew-symmetric matrix, so this is skew-symmetric matrix. Okay. I have told you what is a symmetric matrix. When A dash, that is transpose of the matrix, is equal to A, we say it is a symmetric matrix. Similarly, if A dash is equal to minus A, we say it is skew-symmetric. So this you know, so you are familiar with this. We'll see some questions. First is, the question is, if A is a symmetric matrix, then prove that Ka is also symmetric. This is symmetric, then prove that this is also symmetric. See, A is symmetric, this means A dash is A. Now Ka dash, when can we say that Ka dash is symmetric? When Ka dash will be equal to Ka. From the scalar property of matrix, we know that in this case K can be taken out, so this is actually equal to Ka dash, but A dash is equal to A, this is given, so this is Ka. Now see, Ka dash is equal to Ka, therefore K is also symmetric. Proved. In this question only, it says that A is skew-symmetric. Prove that Ka is also skew-symmetric. A is skew-symmetric, meaning A dash is minus A. Now for K dash, Ka whole dash to be skew-symmetric, this should be equal to minus Ka. Let's say K is a scalar, we can take it out. So this is now Ka dash, but from here we get A dash is minus A, that is this is K into minus A. This is again a scalar, multiplication by minus 1, so we can take it out. So this becomes minus Ka. Now this is equal to this, therefore this is also skew-symmetric. Okay. The second question is, A and B, they are symmetric matrix. Symmetric. We have to prove that A plus B is also symmetric. How can we prove? See, we take transpose of A plus B, that is equal to, from definition we know this is equal to A dash plus B dash, but A and B are symmetric. What is the meaning of this? This means A dash is equal to A and B dash is equal to B. This is by definition, therefore this can be written as A plus B. Now see, this is a matrix transpose of which is equal to the original matrix, therefore this is also A plus B dash is equal to A plus B. This means A plus B is also symmetric. Okay. Now in this question only, it says if A and B dash are skew-symmetric, in place of symmetric, these two are skew-symmetric. What is the meaning of this? This means A dash is equal to minus A and B dash is equal to minus B. The question says, prove that A plus B is also skew-symmetric. How can we prove? Let's see. What is its transpose? Its transpose is this. This we know. A plus B transpose is A transpose plus B transpose. But this is minus A and this is minus B. Or we can take minus out. This becomes A plus B. Now A plus B dash is equal to minus of A plus B. This means A plus B is Skew-Symmetric? Proved. Now third question is, A and B are symmetric. Prove that AB is symmetric if and only if AB commute. This is our question. First of all, what is the meaning of commute? Commute means if A and B commute, this means AB is equal to BA. Clear? This is the meaning of commute. It says if these are symmetric, prove that this is symmetric if and only. Again, what we have to do is, first of all, we'll say okay, it commutes. First way, it commutes. That is AB is equal to BA. Then let's see whether AB is symmetric. Let's see. AB dash, this is B dash A dash, you know, multiplication of matrix, product of matrix, transpose, you take transpose of product of two matrices, this will be in reverse. Now B dash is B, these are symmetrics, therefore A dash is A, B dash is B, so this is BA. Now we have taken in this case that AB is equal to BA, that is AB. Therefore first case, that when the two matrices commute, these AB dash is equal to AB, that is AB is a symmetric matrix. From here we get, therefore AB is a symmetric matrix. Second, let's say our AB is a symmetric matrix. Then second is, let's say AB is a symmetric matrix. Then we have to show that they commute. See, AB is symmetric. What is the meaning? This means this is equal to AB. Saying that AB is symmetric, this means this. But we know that this is B dash A dash, and we are saying this is equal to this. But from here, A and B are symmetric. A equal to A dash, B equal to B dash. So this is BA. Therefore, if we take AB as symmetric, they commute also. So we have proved that first, when AB is equal to BA, AB is symmetric, and second, that when AB is symmetric, AB is equal to BA. Therefore, we have proved that AB is symmetric if and only AB commute. Clear? Next question is, it says A is a matrix. A is a matrix. To prove that AA dash and A dash A are symmetric, we have to prove. Okay, let's see how. Let's take first. This is first matrix, this is second matrix. If this was AB, transpose of this was BA. First of all, we'll reverse and then we'll take transpose. That is reverse and then take transpose. Okay. Now transpose of transpose is the original matrix. So this is, I haven't put this. This is AA dash. Now you see, transpose of AA dash is equal to AA dash. Therefore this is symmetric. AA dash is symmetric. Proved. The second one, A dash A. A dash A. Let's take its transpose. So we'll have, first of all, we'll take transpose of this, that is A transpose, and then this one. So this is A dash dash of this. What is this? A dash, and this is transpose of matrix is A. So see, A dash A is equal to A dash A. That is transpose of A dash A is equal to transpose of this. Therefore, this is symmetric matrix. Now next question is, it says A is a square matrix. We have to prove that A plus A dash is symmetric and A minus A dash is skew symmetric. Let's see, A plus A dash, transpose of A plus A dash will be A dash plus this. This is equal to A dash plus A. And we know that in a matrix A plus B is equal to B plus A. Therefore, this can be written as A plus A dash. Now what you see? Transpose of A plus A dash is equal to A plus A dash. Therefore, A plus A dash is symmetric. Proved. A minus A dash. Let's see. Transpose of this. this will be A dash minus this. This is A dash minus A, or if you take a minus, what you can do? This will come to this side and this will come to this side. What is this? A minus, transpose of A minus A dash is equal to minus of A minus A dash. Therefore, this is skew symmetric. This is why we write like this: half of A plus A dash plus half of A minus A dash. That is, any in square matrix can be written as a sum of a symmetric and skew-symmetric matrix. This is the theorem. Clear? This is an example. We have to express this matrix A as a sum of symmetric and skew-symmetric. That is what we have done. This is equal to half A plus A dash plus half A minus A dash. This is symmetric, this is skew-symmetric. So we have to express A in this form. Let's see. A plus A dash. First of all, let's see what is A plus A dash. 2 minus 2 minus 4 minus 1, 3, 4. 1 minus 2 minus 3 plus A dash. A dash is 2 minus 1, 1. 2 minus 1, 1. Minus 2, 3. Minus 2, minus 4, 4, minus 3. Let's see what is the value of their addition. 2 plus 2, 4. Minus 2, minus 1, minus 3. Minus 4, 1, 3. Minus 1, minus 2, 3. Minus 3. 3 plus 3, 6. 4 plus minus 2, 2. 1 minus 4, minus 3. Minus 2, 4, 2. Minus 3, minus 6. Okay. Now we have to take half of this. So half of A plus A dash, I am writing it here, is equal to, see, 2 minus 3 by 2, 3 by 2. 2 minus 3 by 2, 3 by 2. Then minus 3 by 2, 3. Minus 3 by 2, 3. And this is 2. So this is 1. Then minus 3 by 2. 1 minus 3. See whether it is symmetric or not. See, row and column, that is A dash is equal to A. Therefore, that is a symmetric matrix. Now let's see the second part. A minus A dash. A. 2 minus 2 minus 4, minus 1, 3, 4, 1 minus 2 minus 3, and minus of A dash is minus A dash. 2 minus 1, 1, minus 2, 3, minus 2, minus 4, 4, minus 3. So this minus this minus this 0, this minus of this, that is 1. So minus 1, minus 4, minus 1, minus 5, minus 1 plus 2, 1, 3 minus 3, 0, 4 minus 2, that is 6, 1 minus 4, 5, minus 2 minus 4, minus 6, minus 3, minus plus 0. Obviously, the diagonal elements must be 0 because this is a skew-symmetric matrix. So this is our A minus A dash. We have to take half of A minus A dash and express A as half A plus A dash. That is that matrix. 2 minus 3 by 2, 3 by 2, minus 3 by 2, 3, 1, minus 3 by 2, 1 minus 3. So this is half A plus A dash, and then plus half A minus A dash. This is A minus A dash, half of this. This is 0, minus 1 by 2, minus 5 by 2, 1 by 2, 0, 3, 5 by 2, minus 3, 0. So now the matrix A has been expressed as sum of a symmetric matrix and skew-symmetric. You can check this is skew-symmetric, this is symmetric, and if you add the two, you will get this value. See, 2 plus 0, 2, 3 plus 0, 3, minus 3 plus 0, 3. So, diagonals are same. We have done some mistake. This is minus 3 by 2. So, this is minus 3 by 2. So, this see, minus 3 by 2 plus half. So, this is minus half, minus 1. Here 1, minus 3 by 2 plus 5 by 2, 1. So, you can check also. This is symmetric matrix and this is skew-symmetric. Clear?